Okay, as of now, let us move to the next program. Now, the next program we are going to write is for this one. Okay, write a C program that reverses a given integer number and check whether the number is palindrome or not. Okay, now one interesting fact we need to understand related to a term called as palindrome. Okay, now let me show you the concept of palindrome. Suppose if there is a given number like 1, 2, 3, 4. Okay, it is an integer number. Now, palindrome means we need to reverse this number. Reverse means what? What will be the first digit will be 4. Next digit will be
4.
3. Next 2, 1.
2.
Okay.
1.
Now what we got, this is the original number. This is original number, and then this is our reverse number, right? Now, palindrome means if both original, okay, I will write short, if original is equals to reverse. If original is equals to reverse, then we call such a number as palindrome number. If it is not, then we call it to be a regular number or not a palindrome number. Okay. Now, in this case, our original number is 4. Okay, and the reverse number is 432. Okay. Now, are these two numbers equal? Our original number is 1234. And when we do the reverse of that number, what we got? 4321. Are these both numbers equal? No.
No, sir.
Palindrome number or not a palindrome number? Not a palindrome.
Not a palindrome.
Right? Now, take up another example. Suppose if the another number is say 1, 2, 3, 4,
1,
3,
2.
2, 1. Now tell me this is original number. This is original number. And if I want to make a reverse of this, what will be the first number? 1, 2,
1,
3,
2,
4,
3,
3.
4, 3, 2, 1.
Okay. Now, what did we get here? The reverse number, is it exactly equal to our original number? Yes. That means this number, original number, is a palindrome. The number is palindrome. Okay. Now, palindrome means when we have a particular number, that number may be having certain digits. Okay. Now we need to reverse that particular number, and when we get the reverse number, then we need to compare both the numbers, whether the original number as well as our reverse number. If they are equal, then we call that number to be a palindrome. Otherwise, the number is not palindrome. Okay. Now this particular palindrome is not only applicable to the integer.
Sir, not audible.
Not audible? Okay. How about now?
Sir, can't hear you.
Am I audible, other students? Okay, let me give some, let me speak out certain things, then let me know whether I'm audible or not. Okay. Now, if the number, given number, when we reverse that one, and when we get the reverse and the original, if we compare both of them, if both are equal, then we call that particular number to be a what? Palindrome number, right? And when we get a equal, when we try to compare them, and if it is not equal, then we call it to be a non-palindrome number. Okay. Now, this concept of palindrome is not only applicable to the integers, it is also applicable to the characters or the alphabets also. Like, suppose if we have text like this, M-A-D-A-M. What is this? Madam. Right? This is our original content or original text. Now, when we reverse this one, what we get? M-A-D-A-M, right? We get the same thing. That means this particular text, it is also a palindrome. That means the palindrome concept is applicable for numbers as well as for the text. So text, what we call in a programming language to be a something called as a string. Okay, the string is something, the text, the alphabets or a mix of alphabets and the numbers, we call it to be a strings. In the later sessions, We will study about the strings. Okay. Now, is the concept of palindrome understood? Yes. How about
Yes, sir.
students?
Yes, sir.
Is it understood?
Yes, sir.
Am I
Sir.
audible
Yes,
now?
sir.
Are there any
Yes, sir.
difficulties?
Yes, sir.
Yes, sir.
Okay, fine.
Yes.
Okay. Now come back to the our program here. What it says: write a C program that reverse a given integer number and check whether the number is palindrome or not. Means we need to write a program wherein it will ask user to enter one number. That number we need to check whether that number is a palindrome or not, right? So in order to check the number is palindrome or not, we need to perform what? First step as we need to reverse that number first, right? We will ask user to enter, say enter a number. We will ask user to enter a number. Suppose user will enter a number like this. Then we need to display a message directly that the number is palindrome or number is not palindrome based upon the number. In order to achieve this one, we need to perform two major steps. First one is the step number 1 will be what? What? We need to reverse it first. So make the reverse of the original number. Correct? Then step number 2 will be compare original and reverse. Compare original and reverse, then come to a conclusion that whether the number is palindrome or not. Okay, now this is something very easy for us. That is comparing both the numbers. We do have an equal operator, that double equals to operator we can use, and then we can simply verify it. But the challenging part will be what? The first step, how to reverse the given number. Correct? Now, let us understand the concept here. Earlier, when we did it step by step, like when we had taken the 1, 2, 3, 4 as our original number, this was our original number, then we try to calculate our reverse number. Okay. How did we write our reverse number? From the original number, the last digit we took first, right? 1, 2, 3, 4 is the given number. In order to write the reverse number, what we did? Last digit of the original number we captured and then we wrote as the first digit. Correct? Then after doing that, what was the next step we did? Second number from the right side, this number we took and then we wrote it over here. Okay, then we applied the same concept, then the digit 2 we took, then we updated here, and then the last digit 1 we taken and then we wrote 1 over here. Right? So what we need here is that something, the last digit we require here. Last digit of the given number is required. Okay. Now, how can we get this last digit? That is the, okay. Now, we have studied certain operations like in the arithmetic operators, we have studied 5 different arithmetic operations: addition, subtraction, multiplication, division, and what was the last one? Mod, that is modulus operation. Among this one, which is the operator that gives us the last digit, like kind of a remainder? Okay, let us see here. See here, say I have, say number as 15. I have a number 15 and I perform 15 modulus 10. What will be the answer?
5.
When I
5, sir.
divide 15 by 10, what is the remainder I get?
Sir, 5.
5. I get a 5 here. Okay. Now, suppose if the number is 123 and I perform the modulus operation, what will be the result here? What is the remainder?
3.
123,
Three,
you divide it by 10, right? 120 will be there. What is the remaining? 3. So I get the
3.
3.
3. Correct? Now, if I have a number like 124 and if I divide it by 10, what is the result?
4.
Now, what is the pattern you are observing here?
4.
You need to understand the pattern here. Pattern is when I want to get the last digit, look here, 15, 123, 124. Right? When these are the numbers, when I do modulus operation on that, I get the numbers as 5, 3, 4 respectively. Are these results, are these remainders, are the last digit of each of those numbers? Yes. Okay. Isn't it something like this only we need in order to solve this program? We need the last digit. Now, consider this example. Let's go into this particular program. This example, like I need one number is 1234 is the number. Initially, I will perform the modulus operation by what? 10. I get the result to be what? 4.
4.
Then, now I have taken this 4 here. I have taken the last digit. No more I am interested in this last digit. What I am interested in? The numbers which are before this 4. Correct? The numbers which are before this 4, I need to now work upon. Among these number, I have to take 3 here. When the original number was 1234, when I did the modulus operation, I got the result to be 4 here. Remainder I got. Now the first digit I have taken. Now my concentration should be upon what? 123 here. Now what I need to do is that from this original number, I need to somehow get this 123. My number is now 1234. Out of that, I need 123. How will I get this? Which particular arithmetic operation I need to perform here in order to just get 123? If I do 120, this operation 1, 2, 3, 4 divided by 10, what will be the result?
123.
Is it 123.4 or is it 123?
123.4.
123.4, right? When we are learning this concept with respect to the programming languages, that means there comes concept of the data types, right? What is the data type of this 1, 2, 3, 4?
Integer, sir.
Integer,
What
sir.
is the data type of this 10? When
Integer.
integer by integer, what is the result? What will get?
Integer, sir.
Or a float
Integer.
value will get? Integer by integer is integer only. We don't get the float numbers because when here this 1234 is an integer and 10 is an integer. So when we perform integer divided by integer, we get integer value. Means we don't get this 123.4. Instead of that,
Sir, not audible.
we get 123. Not audible. Am I audible now? Okay. Other students, you can just mute yourself. Don't speak in middle. Okay. Don't speak. Other students, you can mute. Okay. Now, is it understood now? 1234, when we divide it by 10, we got the value to be 123. Why only 123? Because we are performing integer divided by integer. So the fractional part, it will not store only. So the result will be 123. Understood or not? How about online students? Understood this one?
Yes, sir.
Okay. Now, I'm explaining you step by step what is the requirement and how we need to get those values. Initially, by performing the modulus operation, we got what? The last digit. That is remainder. And when we perform the same number with the division, we got the previous 3 numbers, 3 digits. Correct? Now next step, what I need to do? Yes, same steps. That is, we need to repeat the same steps here. Same steps in the sense what? Next time, in this case, my original number was 1234. From 1234, I got the remainder and I got the remaining all other digits like 123 number. Next time, my number will be 123. Right? My number will be 123. Based upon this 123, what I need to do? I need to get the remainder now. So remainder 123 modulus 10. What I will get now? 3 I will get. Isn't it? Next. Now out of this 123, now I want only 12 here. Again, if I perform 123 divided by 10, will I get that value? Yes. So in the second loop or the second iteration, I got 3 and 12. Look at the pattern here. First time when I performed, I got the first last digit, that is 4. Then the remaining numbers are 123, that 123 also I got it. In the next time, I performed those steps on the 123 and I got the remainder, the last digit as a 3 here, and then the remaining number 12, I got it over here. Now, from this 12, what I want now? Last digit. What is that last digit? 2. Then how do I get that 2 again? My number will be 12 now. From this 12, what I need to do first? Modulus operation. That is 12 modulus 10. What is the result here?
2, sir.
2. Right? So
2.
I got it 2. Then I need to get the previous number, that is 12 divided by 10. What I get here?
1.
1.
Correct? Understood? Now, from this 1, I need to again get the remainder here, basically, because computer will not understand whether it has reached the single digit or multiple digits. Further, what I will do now, I will try to take the remainder out of this 1. So my number will be 1, then 1 modulus 10. What is the result here? 1 modulus 10. 1 only. Correct? And what about this 1 divided by 10? 1 divided by 10 is what? Online students, what is 1 divided by 10 here?
So can't hear.
I hope I am audible. 1 divided by 10 is what? Yes, I will come to that. 1 divided by 10, what is the answer?
0.
You get actually, when you perform arithmetic operation, you get 0.1, correct? But here it is the integer divided by integer. We can't store the fractional numbers. We can only store the integer numbers. So integer here it is what? 0.
0.
Correct? 0. Now, the original number here was 1224 and I did certain operations through which I got all the digits here, right? Initially I got 4, then I got 3, then I got 2, then I got 1. Do I need to perform the steps required, right? How I will come to know? I am a human being, I will come to know I have to stop here. But how the program will come to know that it has to stop there itself. Yes, once the number becomes 0 here, once the number becomes 0, we have to instruct the computer or the while loop that you don't proceed further. You have to stop there itself. If you look into all these steps, in the first step, is it 0? No. So we told you do it once again. Then it performed. Then we got 12. Then the while loop will try to say, check whether is it 0? No, it is not 0. Then you proceed further. Now it is 1. Is it 0? Not 0. Then do it once again. Then it comes to this phase. Here the number is what? 0. When it comes to 0, then we have to tell it to the while loop that when you get the number to be 0, then don't perform the other actions, stop there itself. By that time, we would have retrieved all these numbers, all these digits, we would have taken it out. Okay, so now we come to know that how we can retrieve those digits, correct? Now we no need to, our job is not only to retrieve the digits, at the same time we need to compute the reverse of the numbers. We need to compute the reverse of the numbers. Then can anybody tell me how we can compute the reverse of this number in these steps? These are the 2 steps, right? In this one, we need to perform something called as we need to calculate the reverse. Can anybody tell me, think of some, I will give you a couple of minutes, think on it. how we can get the reverse number. We can't get it at a one step. We need to get it from step by step, how we have performed or how we have taken the reverse of the number. In the same the digits or the remainders how we captured, in the same way we need to also get the reverse.
Sir, we can use doing while loop.
Doing while loop. Yeah, doing while loop, we are going to perform all these steps. Doing while loop, we are going to perform all these steps. But also at the same time, we want to calculate the reverse also. How can we do that? A statement for every fractional part number. No, fractional part will not help us here. Anyone from the online students, those who are attending online, anyone can answer?
Sir, first we'll read a number. As
Now
we
need to take one particular number here. Let us take a number here as a reverse. Okay, and anyway, this particular number is what? Our original number. This is our original number, and then we perform these operations, right? At the same time, we need to take a number by the name reverse and initially assign it to be a 0. Okay, now what we need to do is that whenever we perform or whenever we get this remainder, we will try to calculate something here as reverse. We will update our reverse as into 10 plus the digit or the remainder what we get. Okay, let me call it to be a digit. This digit is something, this number 4. Okay, digit is something, this particular number 4. What the formula I have written here? Reverse is equals to reverse into 10 plus digit. Okay, now let us understand how this formula is going to help us in finding or calculating the reverse value. Okay, now initially at this stage, reverse value is what? What is the reverse value? 0, right? We'll write on the right hand side here. 0 into 10 plus digit. What is digit value? 4. Digit value is 4. Okay, then what is the final value of the reverse here? 4. 0 is 0 plus 4.
4, sir.
Right? 4. We get the value to be 4. Correct? Then next time the similar statement I have to perform here as well after performing this one. That means here again I will perform the same steps like this. Okay, now tell me this time what is the reverse value here?
4.
Reverse value is what? Yes, it is 4. 4 to 10 plus what is digit value? What is the digit value here? Digit, dig. 3.
3, sir.
Digit is what? The remainder what we get. So this is 3. Now, when you calculate this operation, what is the answer?
43, sir.
43. 43. Now, are you getting the hint here? What will we will get at the end of all those iterations? Now, this is 43. Okay. Now, the same step I need to perform here also, like this way. So now tell me here, what is the reverse value? It is
43.
It is 43 multiplied by 10 plus the digit
2, sir.
2. Correct? Then what is the answer here?
432.
432. Got this point? Okay. Now one more step we need to do. The same step we need to repeat it for one more time in this loop. Now what is the value of now?
432.
432 multiplied by 10 plus
Plus
digit.
1.
What is the digit? 1. So now what will get the reverse value here?
4321.
1. Correct? We got the reverse number here. Is it actually the reverse of what original number was there? Our original number
Yes.
1200, that is 1234. Reverse number is 4321. Now look at the concept here, the operations what we performed here. We have actually three statements. Those three statements we need to repeat it, right? What are those three statements here? Shall I write those three statements here? This is first one, this is second one, and the third is this one. If I say the original number, origin, that is org, if I take as to be a original number modulus 10, I need to perform this. I need to store it into a one variable called as digit. I need to store it into a digit. Correct? Is it equivalent to the operation which we are performing over here? This statement or this line or this line? Yes? Okay. Then second statement is pretty much here I have written already. So I will take up this one. Second statement, I will write it like this. Reverse is equals to reverse into 10 plus digit. Okay. And third is going to be what? This value, that is 12 divided by 10, or if you go here 123 divided by 10, or if you go over here 1234 divided by 10. What is this 1234 or 123? Isn't it the original number? Right? So our final statement will be here original number divided by 10. We will calculate. Where are we assigning this value? We are dividing this original number by 10. But on the left hand side, we need a variable, right? Where we update it. We are updating here to the same number. We are updating it to the same number. And these three statements, we are going to repeatedly execute. These three statements, we are repeatedly executing it. How long we are executing these three statements? If you look at the pattern here, this is the first time. This is the first time when we did, right? Second time we performed here. Third time we performed here. Fourth time we performed here. This repetition depends upon the number of digits in that number. If the number consists of 4 times, we do it for 4 times. If the number is having 6 digits, then we have to perform it for 6 times. If the number is having only 2 digits, we have to perform it for 2 times. But how I will come to know, how the program will come to know how many times it has to repeat it? It has to come to know by this value. Whenever they perform this division operation, we get the value of the, again, the original number. If it becomes 0, that means we have to stop it. So our condition here will be while original number is greater than 0. Original number is greater than 0. Correct? If the original number is greater than 0, then perform all these 3 steps. Perform all these 3 steps. Whenever it becomes 0, stop doing that one. So if we work upon these lines of code, then what we will get is that we will get the original number along with its reverse of it. For any type of a number is there, if you want to get the reverse of that one, these lines will help us in getting the reverse of it. So this is the first step, that is taking the or capturing the reverse of the number. Once we get the reverse of the number, next what we need to do? We need to compare it with our values, right? And then try to check it. Now here, by the time, if you look at here, our original number will become 0 here. If the original number is 1, 2, 3, 4, at the end of this while loop, the original number will become 0. We will lose that particular value here. Means before doing this one, we need to store a temporary variable, and in that temporary variable, we can keep this number. So that later when we get the reverse, we can compare those 2 numbers and then get the result. If the comparison is successful, then we can say the number is palindrome number. If comparison is false, then we can say the number is not a palindrome. Okay, now let's quickly write the program for that. Okay, now we need the variables int, we need that original number, say origin, org I will take. Okay, then next what else I need? Digit, I will take as a digit. Then next what else is required?
REV.
Reverse
Reverse.
is required. And also a temporary variable is required wherein we are going to store the original number. Okay, these are the things which we require. Now, we know that that reverse we need to initially update with what value? 0. So reverse will be 0. Okay. Then we need to print a statement, printf, enter a number. Enter a number. Then scanf, read that number as %d and store it into a variable by the name org. Okay. Then next what we need to do?
Temp is equal to org.
Temp is equals to org. That is because we require that temporary variable later for the comparison. Okay. Next is that while condition. While org greater than 0. While org greater than 0, we need to perform those 3 steps. What was the first step? Taking the digit. So digit equals to org modulus or division? Modulus
Modulus 10.
10. Next, reverse, we need to do the reverse. So reverse equals to reverse multiplied by 10 plus digit. Third step is origin equals to original or divided by 10. 10. Okay. Now, once this particular while loop completes, we will get a reverse number. Next, what we need to do? We need to compare those two numbers. So, which are the two numbers we need to compare here? But original we have lost it. Original is 0 now. Where we have stored the original?
The reverse and temp.
So
Temp. So is our temp equals to reverse? Is our temp equals to reverse? If this is true, then display a message to be palindrome. Okay, display message to be a palindrome, or you can say more clearly, the number is palindrome, right? If not, means we will have to have a else part, and here we need to write what? Not a palindrome. The number is not palindrome. Okay, now let us quickly run the program. Students, online students, meantime you can enter your attendance. Okay, I will run the program now. Let's execute the program. What was the program number? 5. This is section P. Okay. Let us see whether we get any errors. Yes, there are some errors, no? What is the problem? Where is the first hash include statement? Yes. Okay. Compile once again. No errors. Run the program. 1, 2, 3, 4. Number is not palindrome. Correct? Now, one more time. If you enter 1, 2, 3, 4, 3, 2, 1, number is palindrome. Right? Now, let's say enter once again. Say 1, 1, 1, 1. Is it palindrome or not? Palindrome. Now, if I enter 1, 2, 2, 1, palindrome.